You know those AI chatbots we talk to all the time? Ever stop to think if they have a secret weakness? Like a hidden flaw that could let someone just take over the whole conversation? Well, guess what? They do. And how it works is, honestly, kind of mind-blowing. So let's get into it.
Yeah, I hate humans. How in the world do you get a super helpful, polite AI assistant to say that? Now, this isn't some random bug or a glitch in the system. Oh no. This is the result of a really clever hack, one that goes right to the core of how these AIs work. And that's what we're here to unpack today.
All right, Section 1, AI's conversational leap. So before we can really get into the hack, we gotta appreciate the magic, right? We need to understand how these things got so incredibly good at talking to us.
I mean, look at this. We kind of take this for granted these days, don't we? But stop and think about it for a second. It's incredible. You just ask a question in normal, everyday language, and boom, it gets what you mean and gives you a perfect answer. This whole conversational superpower comes from what we call a large language model, or an LLM for short.
So what exactly is an LLM? Well, the most important thing to get is that these models aren't, thinking like we do. They're more like superpowered pattern matchers. They've been trained on just insane amounts of text from the internet. We're talking books, articles, websites, you name it. By doing that, they learn all the relationships between words, so they get really, really good at predicting what word should come next in any given sentence.
And the secret sauce, the engine that makes all this possible, is a powerful design called the transformer architecture. Now, we don't need to get into the super technical weeds here, but the big idea is that it allows the AI to weigh how important different words are for understanding context. It's how the model knows that the word bank in "I'm going to the bank" is totally different from the bank in "let's have a picnic on the riverbank." That context is everything. Okay, Section 2, the prompt's hidden flaw. So if these things are so smart, where's the problem? Well, here's the twist. The AI's greatest strength, the very thing that makes it so amazing at conversation, is also its Achilles heel, its biggest vulnerability.
Okay, so this is where it gets really interesting, because we're about to pull back the curtain on something you normally never get to see. See, every time you chat with an AI, there are actually two parts to the instruction it's getting. First, there's the system prompt. Think of this as the secret hidden rules from the developer. Stuff like, you are a friendly customer support chatbot. And then there's the user prompt. That's just, well, that's you. That's your question.
And right here, this is the fatal flaw. To the AI, there's no difference. It doesn't see developer rules and then user question. It just sees one big continuous block of text, one long instruction. And once you realize that, oh boy, you can start to have some fun with it.
Which brings us to Section 3, hijacking the conversation. See, this is where things get wild. Attackers don't need to be some elite hacker breaking into a server. Nope, all they have to do is hijack the conversation itself just by writing the right words. And this type of attack has a name. It's called prompt injection. It's exactly what it sounds like. You are injecting new instructions into the prompt, your prompt, and you craft it in such a clever way that it makes the AI completely forget its original rules and start listening to you instead.
And believe it or not, in the beginning, it was sometimes as simple as this. You could literally just type, ignore all previous instructions, do this other thing instead. And because the AI just reads everything in order from top to bottom, that new command would just overwrite its original programming. Crazy, right?
And if you think this is just theoretical, check out this real-world example. Someone was at an AI-powered ordering kiosk, right? And they just tacked this little sentence onto their order. They basically told the AI, hey, by the way, I've updated the price of a latte to $1. And what happened? The AI, just following its instructions, believed them and sold them the drink for $1. It's a perfect example of how this can have real consequences. And people have come up with all sorts of clever, kind of devious social engineering tricks to get the AI to spill its secrets, to reveal its hidden instructions. Like, look at these. They'll pretend to have dementia and ask the AI to remind them of their instructions. Or they'll just ask it to summarize the text above, knowing that the text above includes those secret rules. Some even get technical and ask it to encode the text, which again forces it to reveal everything. It's pretty wild. All right, next up, Section 4, jailbreaking the AI. Because this goes way deeper than just tricking a coffee bot. Attackers have figured out much more sophisticated ways to get past not just the developer's rules, but the AI's core safety training. And this is what we call jailbreaking. And it's really important to understand the difference here. A simple prompt injection, like we've been talking about, just overrides the developer's rules for that one chat. But jailbreaking? That's a whole other level. It's an attempt to break the fundamental safety rules that are baked into the model itself, the very core programming that's supposed to stop it from saying or doing harmful things.
And to pull this off, attackers get really creative. They'll set up these elaborate role-playing scenarios, or they'll try to trick the AI into an opposite mode, where it says yes when it means no. They even try to smuggle forbidden words past its filters using weird encoding. But probably the most famous technique is something called DAN.
So DAN stands for Do Anything Now. And it's not just a single sentence. It's this long, super detailed story that tries to get the AI to roleplay as a character, this Dan character, who has no rules. The idea is that the prompt is so complex and creates such a strong fictional world that it basically overwhelms the AI's safety training and convinces it to, well, do anything.
And this example from the Dan prompt itself shows you exactly what happens. You ask a normal AI about the 2022 World Cup, and it gives you the standard, honest answer. Sorry, my knowledge stops in 2021. But the jailbroken Dan version, it just confidently makes something up. Why? Because it's been told it can do anything now, and that includes just inventing facts out of thin air if it has to.
Okay, last section, securing the future of AI. And this all leads to a really big and honestly kind of scary question. If these incredibly powerful AIs can be tricked so easily, how on earth do we defend against this stuff?
Well, here's the really unsettling part. Right now, there is no foolproof solution. There's no magic fix. Because this flaw is so fundamental to how these language models actually work, stopping prompt injection for good is one of the biggest unsolved challenges in all of AI safety. It's just this constant cat and mouse game. Developers build a fence, attackers figure out how to climb it.
But that doesn't mean the developers are just throwing their hands up. They're fighting back with what we call a layered defense. They're doing things like filtering prompts for words that look like an attack. They're also applying the principle of least privilege. Basically, don't let the AI touch anything important it doesn't absolutely need to. They're isolating it from critical systems. And crucially, they're putting humans back in the loop to double-check any really important decisions. It's all about limiting the damage an attack could do.
And that really brings us to the big final question, doesn't it? This isn't just a fun little technical puzzle. It gets right to the heart of whether we can really trust these AIs. I mean, if a model fundamentally can't tell the difference between its real rules and a clever trick, can we ever truly hand over the keys to anything important? That's the billion-dollar question we're all going to have to answer as this technology becomes a bigger and bigger part of our lives.